Hello, and in this video we're going to carry on a bit more with the integration introduction and touch a bit more on the reverse chain rule. So here we've got a few questions. Let's start with question number 1, the integration of cot squared x. Now with these trig integrations you have to be really solid with your identities. I would recommend memorizing all the identities off by heart before even trying any integration question, especially in the A2, because you're going to have to sort of bring in identities where you wouldn't normally see them and sort of just to help you out. So for example, in this first question, it's not obvious what the integration of cot squared x is. In fact, there's not a really specific integration of it. So what we're going to do is, okay, we're stuck. What do? We're just going to write an identity relating to cot squared x. I know that 1 plus cot squared x is actually equal to cosec squared x. So this might just help me out. Let's just carry on with the identity. Let's make cot squared x the subject. This is the same thing as cosec squared x minus 1. Now, okay, let me work out the integral of cosec squared x minus 1 instead. Okay, and as you probably know, the integral of cosec squared x is quite simply minus cot x, and the integral of minus 1 would be minus x. So can you see that in the beginning we were a bit unsure? So what did we do? We just wrote down an identity of that involves cot squared x, and eventually we got to the answer. Okay, of course you can write plus c as well. So let's try a similar sort of method with the second question. Okay, if we get stuck, let's just bring in an identity, substitute some identity into the question. So we've got let's actually just copy and paste that. The integral of sine x plus cos x all squared. Again, it's not obvious. It doesn't look like it's a reverse chain rule. Let's just expand it out. And if we expand it, we'll get this. Now, the integral of sine squared x, and the integral of cos squared x, there's a long way and there's a quick way of doing this. The quick way is, well, straight away noticing that from AS, this is actually just equal to 1. So I've made my life a lot more easier by identifying as an identity. This, of course, I can't really do much to it. I'm just going to have to keep it as sine x cos x. So let's find the integral of this instead. Okay. The integral of this would be x plus, here's the tricky bit. Where did that come from? This is another reverse chain rule. Okay. You kind of have to do a lot of questions to get the gist of this, but can you tell that this technically came from sine squared x? Because if I differentiate sine squared x, what would I get? Bring the 2 down, right? You'll get 2 sine x, and then you differentiate sine x, you get 2 sine x cos x. And that's kind of what we have, except we don't have the 2. We just got 1. So I'm going to put a half in front of sine squared x. And there you have it. That is the integral. Let us go to the third question now. In fact, I want to change this question. Let's do the integral of cos squared x. Okay. Integral of cos squared x. This looks quite strange. Okay, there's not an obvious integral. Can't come from cos cubed because cos cubed, we'd end up with a sine inside of it somewhere. Let's do the same thing we did question 1. Let's make some identity. You know, what identity involves cos squared x? The classic cos 2x equals cos squared x minus sine squared x. Now, I could make cos squared x a subject, but it looks like that won't really help me. Okay, it looks like this is a bit more sort of tougher to integrate, because this is easy to integrate, but that is not as easy. So let's scrap that. Let's change it to the other form where there's only cos in it. There's only cos. There's only the cos trig value. Okay. Now let's make cos squared x a subject. Cos 2x plus 1 and then divided by 2. This is very easy to integrate. Okay, so instead of using cos squared x, we just changed it to this. Now, I derived it in front of you. However, I would actually say as soon as you see the integration of cos squared x, you kind of need to just memorize this. Cos squared x equals this. So like I was saying before, don't even do these steps. You should just know this step straight away. You should just know that cos squared x is half cos 2x plus 1. That's something that should be embedded in your brain. Okay, and if it is embedded in your brain, look how simple the integration will be now. Okay, this clearly came from sine x. Okay, sorry, sine of some function. Let's just write sine of 2x plus 1 for now. We know it definitely got something to do with that. The problem is if we differentiated that, we'd have a 2 in front of it, but there's a half. So how do I go from 2 to half? You put a quarter in front of it. Finished. This is your integral. Okay. Let's go to the next part. So these are a bit more reverse chainal questions. I don't think we'll go through all of these, but let's get the general gist of it. Okay. If I've got, let's go for the first question. Integration of 2x over x squared plus 1. Now, with fractions, if you can recognize that the top is the differentiation of the bottom, straight away you can say that this is equal to ln of the bottom. Okay, this is something you should be able to spot straight away. This is the reverse chainal, because what happens if I differentiate ln of x squared plus 1? Or what's the differentiation of x squared plus 1? 2x. What do you put that all over? You put it all over x squared plus 1. Okay, so as soon as you see the derivative of the bottom at the top, you should straight away write ln of the bottom function. Okay. Let's do the second question. Integration of cos x over 3 plus 2 sine x. And again, this is clearly the differentiation of the bottom is at the top. Okay, so it's definitely something to do with ln of 3 plus 2 sine x. The only problem is if we did actually differentiate this, we wouldn't perfectly get this because of that 2 in front of the sine x. So in fact, let's just put a half in front of the ln. Okay, that would cancel out and we'd successfully get the original integral. Okay. Again, if you feel like this is going too fast paced, you don't understand what I mean by put the half in front, please go back to part 1 where it's described a bit more in detail. Okay, but basically it's to cancel out this 2 so that there's no coefficient. There was no coefficient here, isn't it? It was just 1 technically. Okay. Let's try one more question. Let's do one more question. Reverse chain rule. This is a good one. 3 cos sine squared x. Okay. Now, just by looking at it, it's not okay. This is a very strange question. How are we supposed to integrate this, right? You have to recognize that this must have come from sine cubed x. Because if you differentiate sine cubed x, what do you get? You'll get 3 times, then you differentiate sine x, cos x times cos squared x. Do you see that? You have to be able to differentiate perfectly for you to see something like this. In fact, I wrote the wrong thing. Sine squared x, sorry. And look, it's exactly what the integral wanted it to be, right? I don't even need to adjust it, okay? So reverse chain rule is when you sort of suspect that, okay, this integral has something to do with this, and then you differentiate it and see if, you know, you need to adjust it or something like that. So for example, if this was a 6, you'd realize that, oh, I'm a bit short. There should have been a 2, right? So you just put on a 2, no problem. Okay, and there we have it.